Alright guys, in this video, you're going to learn every single thing you need to know about esters. Okay, and this is for AQA A Level chemistry. So what do you need to know? By the end of this video, you're going to know the structure of esters. You're going to know that carboxylic acids and alcohols react in the presence of an acid catalyst to give the ester. You're going to know that esters can be hydrolyzed in both acid or alkaline conditions to form alcohols and carboxylic acids or salts of carboxylic acids, depending on the reaction. And you're going to know the common uses of esters. Okay, this is all directly out of the AQA specification. And at the end of the video, I'm going to run you through a few practice questions just to test your ability, do some active recall from the content you just learned, and get yourself prepared as much as possible for those exams. Right, so let's start with an ester structure. Okay, you need to know how to draw these as well as how to name them. So I'm going to pop one really simple example on the screen here in a second, and let's work out what functional groups are involved and how to name an ester. Okay, so on the screen right here, I have ethanoic acid. Now you may be thinking, what's going on here? This isn't an ester. The reason I'm drawing this out is because you need to know that esters are derivatives of carboxylic acids. Okay, what does a derivative mean? It just means a byproduct, essentially, slightly transforming it to form a different functional group. Okay, now, how does an ester differ from a carboxylic acid? We just get rid of this H right here and add an alkyl chain. Okay, what is an alkyl chain? Think of something like methyl, ethyl, butyl, things like this, some sort of carbon-hydrogen chain, which I'm going to do right now. So let's say we add CH2, CH3. So this would be an ethyl group right here, 2 carbons in the chain. And this would be an ester. Okay, so the general formula of an ester is going to be R. Let's write that up here, R. R normally just signifies some sort of carbon chain. Now this can be a hydrogen as well, so just keep that in mind, but normally a carbon chain. And then you're going to have the ester functional group. What is that? Q. Okay, just remember it as Q. And then we're going to have another carbon chain, another alkyl chain. And this is just referred to as another R group here, but normally seen as R prime. So R with just like an apostrophe at the top. Okay, these are going to be the 2 alkyl groups on either side of that Q ester linkage. Okay, so how would we name these esters? Really simple. When I was doing my A levels, this sort of structure confused me so much, but once you realize how to name it, it's super simple, right? So all you have to do is focus on the alkyl group. So this R group and this R prime group. What you want to do is you want to name the right hand side of the ester first. So what is this alkyl group? And then you look at the left-hand side and you say, okay, what is this alkyl group right here? And that is how you name it. So the right-hand side is going to be the prefix, the start of the name, and the left-hand side is the suffix. So what would this be then? So if we name the right-hand side first, you're going to have how many carbons are here? 2. Okay, so we know it's going to be eth. So the way that you name an ester is you would start it with eth, that is the carbon chain, and then you just add a Y and a L. So it'll be ethyl, okay? Just as you have in the name alkyl for alkyl chain, you just say, okay, how many carbons are present here? And that will be the prefix of the ester. Okay, so we've named the right-hand side. Let's name the left-hand side. So how many carbons are here? I've made this one pretty simple for you guys, just as a starting example. This is also 2 carbons. So it's not going to be ethyl, okay? That is not how you name this. You want to use the ester part of the functional group within the suffix, which is right here. So it's going to be ethyl, and then we're going to say how many carbons there are. There are 2, so it's going to be eth, and then you're going to end it in anoate. Okay, ethyl, ethanoate. Simple as that, guys. Name the right-hand side, name the left-hand side, and remember the anoate end of an ester functional group. Okay, now this can get more complicated. I'm going to break some down in the practice questions at the end, but you just want to pay attention to how many carbons are in the carbon chain. Now, the main thing that can trip students up here is going to be not including this carbon in the name of the left-hand side, okay? So a lot of students would completely ignore this and they would only look at the number of carbons attached to this carbon. Okay, don't do that. You always want to include the carbon that is bonded onto the oxygen in this carbonyl group right here. Okay, so the next thing you have to be aware of is intermolecular forces, okay? And this is going to determine the boiling point, okay? So something you need to be aware of is that esters have weaker intermolecular forces or lower boiling points than carboxylic acids and alcohols, okay? Why is that? So this carbonyl group right here has a dipole, okay? Electronegative oxygen bonded onto this carbon. So we're going to have a delta positive charge here and a delta negative charge here. You're going to get exactly the same thing occurring between this carbon and this oxygen. Okay, oxygens are electronegative. Essentially, whatever they're bonded to is going to be relatively more positive. Okay, so there's going to be two dipoles induced right here. So what does this mean for an ester? Now, if we go back to our carboxylic acid quickly, we had a CO and an OH. And in an alcohol, you have a C and an OH, right? So these, due to the O and the H and the O and the H right here, these can form hydrogen bonds with one another, okay? And they can also form hydrogen bonds with water molecules, so H2O. Now, the thing you need to be aware of for esters is that this R group, this alkyl chain, prevents the molecule from forming hydrogen bonds with one another. So two different ester molecules are unable to form hydrogen bonds with one another. However, they can form hydrogen bonds with water molecules. Okay, so esters always going to have lower or weaker intermolecular forces because they cannot form hydrogen bonds with one another, whereas carboxylic acids and alcohols can form hydrogen bonds with one another, but they can form hydrogen bonds with this guy right here, H2O. Okay, so just try and remember that. Weaker intermolecular forces, lower boiling point in this guy right here, an ester. Okay? How do they form these hydrogen bonds? Remember, guys, oxygens have a lone pair, okay? So we're going to get a lone pair here, a lone pair here. These lone pairs are going to be attracted to one of the relatively positive hydrogens in the water molecule, okay? And that's how this is going to work. We're going to form our hydrogen bonds here. Right, so that's the structure and the intermolecular forces done, as well as the naming. Next thing we need to look at is how do we form these esters, okay? And you need to know this reaction, the name, and the equation, okay? So what is the name when we produce an ester in this way? So I'm going to draw out an equation for us involving two different functional groups, okay? Right, so I'm going to use my example that I did right at the start, ethanoic acid, okay? What is this functional group? This is a carboxylic acid. So we're going to be reacting a carboxylic acid with a different functional group to form an ester. What is that functional group? An alcohol, okay? Right, so I've just used a real simple example of ethanol, okay? Two carbons in the chain, then we've got an alcohol functional group right here. Now these two are going to react together to form our ester and one other product. That product is water. Okay, so what is this reaction called when you react a carboxylic acid with an alcohol to form an ester? It's called an esterification reaction, okay? Esterification. All right, just remember that. It's really important. Now, the next thing that you need to be aware of is that these reactions are at dynamic equilibrium, okay? So we have this equilibrium arrow right here. What does this signify? This signifies that the forward and reverse reactions are occurring at the same rate. Okay, they can go forwards and backwards. So what are our products? As I mentioned, an ester and water. So how are we going to work out what ester is formed when we react these two together? So you need to know, okay, we're going to slot this carboxylic acid with the alcohol. What ester is formed? Okay, so this is real simple. As I mentioned, all you need to do is get rid of this hydrogen right here and get rid of this alcohol group. Okay, simple as that. And then you're going to slot this part of the alcohol onto this oxygen right here by a covalent bond. Okay, so let's draw that out and see what's going on. So if we draw our starting part of the carboxylic acid right here, ignoring this hydrogen, okay, this is off. This and this form water. Okay, that's our other product. Then all we have to do is slot in this CH2, CH3. Okay, CH2, CH3. Okay, you don't have to show every single bond. I'm just doing this so you guys can see it. And then our other product, as I said, water. Okay, 1 mole of H2O. And that's our esterification reaction right here. Now, there's one really, really important thing that I haven't mentioned so far. What is that? What do we need for this reaction to occur? We need a catalyst. This reaction is incredibly slow. Okay, we need a catalyst and we need to heat it under reflux. Okay, what is the catalyst we're going to be using here? An acid catalyst. Okay, H2SO4. How do we signify that? We just show a H plus right here above this equilibrium sign. Okay, so our catalyst, H2SO4. This is the most common catalyst that you're going to be using for these esterification reactions, and you do need to remember this catalyst, okay? Why do we need a catalyst? Remember guys, I said the reaction is incredibly slow, so we need to provide the catalyst to speed up that reaction, get things moving, and get more product, okay? It won't increase the yield of the product, it will just get you there faster, okay? Now you may see this reaction referred to in a slightly different name. What is that name going to be? Condensation reaction. Okay, that's the overall general term. All right, just remember that. But normally the official name for this reaction is esterification, but sometimes you might see it referred to as a generalized condensation reaction. Okay, so just really running through this quickly. Ethanoic acid plus ethanol gives us ethyl ethanoate, like we named in our very first part of the video, and then we get water molecule kicked off as well. Really important that you remember this. You don't have to show the H plus when you're drawing out these equations in your exams, okay? But you need to be aware of the fact that a catalyst is required, okay? Right, so as I showed you guys in the previous slide, esterification reactions are reversible, right? They can go the other way. You can break down the ester and go back to our carboxylic acid and alcohol. This is referred to as a hydrolysis reaction. Okay, they can be broken down by water. Okay guys, so I've drawn this out, but we've just flipped it around, okay? So we're going from an ester and water to a carboxylic acid and an alcohol. Now, there's two types of hydrolysis reactions that we need to be aware of. This is the first one I'm going to cover, which is when you react it in the presence of an acid. Okay, the other one is going to be in the presence of an alkaline solution. So what is the reagent for this? What acid are we going to be using? Even though you're going to show it as a general H plus like this, the reagent is going to be dilute HCl, okay? Dilute hydrochloric acid. And what is our condition going to be? Just as with our esterification reaction, the condition is exactly the same, okay? I may not have I've written it down, but I did say the condition is heat under reflux. Okay, try and remember that. All the conditions for these ester reactions, the esterification and the hydrolysis, just remember that all the conditions are heat under reflux. So that makes it pretty easy for you guys. So this acidic one, super simple. It's literally just flipping the equation round for the esterification reaction and just remembering that the reagent here is dilute HCl, okay? Let's move on to the more difficult one you have to remember, and this is hydrolysis of esters but using alkaline conditions, okay? What is this reaction referred to as? Saponification, okay? Let's write that down, saponification. Now there's two main things that we need to be aware of here. Firstly, the reaction is not reversible. Let's write that down. Reaction is not reversible. This is really important to remember, guys, because when you're adding an acid for the hydrolysis, it is reversible. We have that equilibrium arrow, whereas this reaction is not reversible. Okay, the second one is it's going to form a carboxylate salt. So let's actually draw out the equation here that you need to know. Just going to use an example one of ethyl ethanoate again, reacting with an alkali. Okay, the alkali you're going to be reacting with is dilute sodium hydroxide. So let's draw out the equation and write out the reagents and the condition. Right, so we're going to be reacting ethyl ethanoate, exactly the same ester here. I'm just using this as an example, but in your exams, this will change depending on what they ask you for. I'm going to react this with good old sodium hydroxide. What is this going to form? I've already said carboxylate salt. So how do we draw that? So let's draw this out. Right, so what you want to do is you want to draw the COO functional group portion of the ester, but you want to ignore the alkyl chain and instead change it for the metal that's present in this alkali right here, so sodium. Now, what I'm going to do is I'm going to draw that right here. There's an extra thing we have to pay attention to, and that's charges, okay? This COO is going to have a negative charge on this oxygen, and the sodium metal is going to have a positive charge right here. Okay, now something you may see under the carboxylic acids topic when you're dealing with these salts is a little dash line, okay, like this, between all the oxygens. All this signifies is delocalization of the electrons, okay? So the electron can essentially exist anywhere in this region, but we won't cover that in this video because it's more to do with carboxylic acids, to be honest. So we'll skip over that. Now, you can also just draw this out a lot more simply. Instead of drawing it, just write out the formula, okay? So CH3COO showing the negative and the positive charges. Okay, that's going to be a more simple way to do it if they don't ask you to specifically draw it out. Now, what is this going to form as our other product here? Alcohol, okay? So what is the alcohol form going to be here? It's just going to be this part of the ester, okay? So for example, this one right here is ethyl. So our alcohol is going to be ethanol, okay? So ethanol, I'm just going to write it out shorthand, CH3CH2OH, because I'm running out of space, but you can draw this out fully, that's completely fine. Now, something I haven't mentioned is if you need to name this carboxylate salt, how would we do it? Exactly the same way you name an ester. Okay, so how do we name an ester here? Remember, right-hand side, left-hand side. Sodium is our right-hand side in this carboxylate salt. So the start of the name would just be sodium. Okay, and then we name the rest of the ester in exactly the same way. How many carbons are there? 2. So it's going to be sodium ethanoate. Okay, sodium ethanoate. That is how you would name our carboxylate salt. Pretty simple, really. Now, as I said, the reaction is not reversible. Notice the forward arrow only here. Why is this? The reason is this right here, this carboxylate salt, it's negatively charged ion. And this is resistant to attack by nucleophiles. Okay, nucleophiles such as alcohols. So this alcohol right here is not going to be allowed to come along and attack this carboxylate salt. That just can't happen. So the reaction is, it's not possible for it to go the other way. Okay, so just remember that fact. It cannot be attacked by weak nucleophiles such as alcohols. All right, that is why the reaction is not reversible. All right, so let's look at our reagents and conditions that you need to know. So what is our reagent going to be? I've already said sodium hydroxide. Okay, is this concentrated? Is it dilute? It's dilute. Okay, dilute sodium hydroxide is our reagent. What is our condition? What did I say it would be already for all of these ester involving equations or reactions? Heat under reflux. Okay, heat under reflux. Pretty simple there. Just remember that one for ester reactions and you're all good to go. What is another caveat that we need to remember? Another condition. Excess dilute sodium hydroxide. Okay, if we use an excess of this dilute sodium hydroxide, it's going to ensure that this ester right here is completely hydrolyzed, okay, completely split up into its carboxylate salt and alcohol, okay? So you're going to want to use an excess amount of sodium hydroxide to ensure that it goes to completion. All right, so that's hydrolysis of esters with alkali done. What is this called, guys? Saponification, okay? Remember that this is not reversible. Let's move on to common uses of esters. All right, there are 4 common uses of esters that we need to be aware of. So let's write down 1, 2, 3, 4. What are these? Okay, they're in the specification. They tell you straight away what they're used for. You don't even need to open a textbook or anything. The 4 are solvents. Okay, so that'll be our first one. Next one, plasticizers. Okay, we'll look at what plasticizers are in a second. What is the third one? Perfume. Okay, nice perfume. And what is the 4th one? Food flavoring. Okay, if you look at the back of a food package, sometimes you'll see esters chucked in there. Okay, food flavorings. All right, so firstly, we're going to look at here, these, even though they're number 3 and 4, is perfumes and food flavorings. Okay, why are they used as perfumes and food flavorings? Because they have pleasant smells and tastes. Okay, a range of tastes and smells, but they're normally pleasant and fruity. Okay, so that's the first thing we have to be aware of here. The main caveat to these two that you need to be aware of, as well as them tasting and smelling real good, non-toxic. Okay, you cannot be using any sort of toxic esters in food and perfume. That is a fat no-no. Okay, all right, so that applies to both food flavorings and perfumes. To perfumes only, okay, they have to be soluble. Okay, and they're normally going to be soluble in an alcohol. Okay, so for example, ethanol. So if you have a perfume, you spray it on you, it's going to contain ethanol most of the time, right? Next one is it has to be volatile. Okay, what does volatile mean? Turns into a gas easily. Okay, it's going to be turned into a vapor really, really easily. Next one is doesn't react with water. Okay, you do not want it to react with water. Okay, that is our conditions for a perfume. I say conditions, but just things you have to remember really. And remember this one the most, non-toxic. It's really important for both 3 and 4. All right, so let's go back to solvents quickly. Number 1 right here. Why can they be used as solvents? Because they are polar. Okay, remember they have the CO carbonyl and the C, I'll draw the other O, and this O right here. These are polar groups right here. Now, remember I said, guys, they cannot form hydrogen bonds. So they can't form hydrogen bonds with one another, but they can form hydrogen bonds with water, and they're going to have a lower boiling point than both carboxylic acids and alcohols. Okay, so they're used in solvents for that very reason. Last one here, plasticizers. Okay. You don't really need to know what a plasticizer is exactly, but it's essentially something that's added to a polymer. Why is it added? It's normally because pure polymers are going to be very rigid. Okay, they have limited flexibility. All right, now if we incorporate some esters, some plasticizer into the polymer, it allows those chains to be a bit more flexible. So let's put that here, added to pure polymers to increase flexibility. So something additional I can actually add here about these plasticizers is the esters are going to reduce the intermolecular forces amongst the polymer chains, okay? And that's essentially what makes it more flexible. So reduces intermolecular forces, okay? IMF, intermolecular forces, just shortened there. And that is why they are used, okay? So that's our common uses done. Let's move on to some practice questions. All right, guys, as I said, perfect opportunity to take what you've just learned from this video and use some active recall. Do your best, pause the video, actually attempt these questions, okay? Do yourself a favor and do some revision. These first 3 questions are going to be pretty easy, okay? And then the next 3 are going to be a little bit more difficult. So if you're really confident with these ones, feel free to skip ahead to the next 3. First one, draw the structure of the ester ethyl ethanoate. All right, real easy one right here. Hopefully you guys are fine with this. Now you can draw it structurally, you can draw it displayed, you can draw it skeletally, whatever the hell works for you. As long as you get it correct, it's all good. All right, so let's do this. Hopefully you guys got this correct. It's actually just the ester I've been using throughout this entire video as an example. So CH3, COO, CH2, CH3. Real easy. Ethyl chain on the right hand side, ethyl on the left hand side, ethyl ethanoate, right? Now you may have noticed sometimes in this video I do H3C like that or CH3. I kind of just do it on autopilot and I switch it up for some reason. I know it's not very consistent, but AQA accepts both, so it's completely fine. Do it however you feel best. The real one should be the H3C, okay, because the bond is traveling from the carbon. The bond is forming from the carbon, not the hydrogen, okay? So the bond is not on here, but AQA accepts both, so we're completely fine there. Right, question 2. Esters are commonly used as plasticizers. I just went through this, guys. Name 2 other uses of esters. All right, so we have 3 other options to choose from. I'm going to choose solvent and perfume. Okay. All right, solvents, perfumes. What is the other one? Do you remember? Food flavoring. All right, cool. That's the 3 other ones you need to remember. You'll normally see this in your exam, okay? They may be real kind with you and just say, name 1 use of esters or something like that, or name 2 uses of esters. Normally, what they'll do to narrow down your choices is they'll get rid of like 1 or 2 already, okay? And that's sort of what I tried to replicate here. But solvents, perfumes, food flavoring, all good, okay? Now, why they're used in solvents, a little bonus here, because of their polarity. Okay, due to their polarity, they can be used as solvents for polar molecules, perfumes, and food flavoring due to their sweet smell and taste, okay? All right, question 3 here. Name the following ester. I've made this one quite easy as well for you guys if you're not too good at naming, but just follow the principles I laid out in the very start of the video. Name the right-hand side, name the left-hand side, slot those guys together, and you're all good to go. So what's the right-hand side here? Ethyl. Okay, real simple one. Again, I just used 2 carbons as an example. Left-hand side, prop. Okay, 3 carbons here. Ethyl, propanoate. Just remember that O8 is always the ending for an ester. Okay, propanoate, ethyl propanoate, not too bad, right? Hopefully you guys are okay with this. Let's move on to some slightly more difficult questions. All right, this one's a bit more difficult. Question 4, explain why esters have lower boiling points compared to carboxylic acids or alcohols. All right, now what is my command word here? Explain. Okay, you're going to see this pop up all the time in your exams. You need to be able to differentiate straight away what the command word is. Okay, so explain here, they're asking for reasoning behind this. So I would write this out in full. I would say esters have lower boiling points compared to carboxylic acids or alcohols, ... because, you don't really want to start a sentence with because, but here we go. Because they do not have the capability to form hydrogen bonds with each other. Okay, so they cannot form hydrogen bonds with each other like carboxylic acids and alcohols can. Therefore, it means they have weaker intermolecular forces and lower boiling points, okay? All right, done. What would our keywords be here, okay? Cannot form hydrogen bonds. This is key, okay? You need to know this. Next part, you would say weaker intermolecular forces. This would probably be like your second mark or a combination of these 2. And then you would have to say that, what does this weaker intermolecular forces mean? Lower boiling point. Okay, this may not be a mark because it's given to you in the question, but it's always good to round off your answer as why this is, because we're explaining it. Okay, question 5. Suggest why a catalyst is required for esterification reactions, and we need to name a suitable catalyst. So do you remember why a catalyst is required? It's because the reaction is hella slow, okay? We need that catalyst to increase the rate of reaction. So that would be my answer here, to increase the rate of reaction. All right, that'd be my first mark here. And we need to name it. Okay, do you remember what the catalyst is that we used? It's often concentrated sulfuric acid, okay? So they've asked us to name it here. So we could just put sulfuric acid like this. And AQA is fortunately quite kind. They would normally just allow the formula as well. H2SO4. You can just put H2SO4. If you want to add the concentrated as well, you can do it like this. Concentrated H2SO4. 2 marks in the bag. Not too bad. I haven't taken these from past papers. I sort of just made them up, but I'm just guessing that it'll be 2 marks considering there's 2 stages to the question. Question 6 here. Last one of the video. Name the following ester. So the reason I've included it in the slightly more difficult questions is because it's skeletal. Okay, and I know some of you guys aren't too confident with skeletal, but it does come up in paper 2 and paper 3 exams, okay? Sometimes they'll ask you to name or draw specifically a skeletal structure. So we're going to follow the exact same principles. Name the right-hand side, name the left-hand side. So how many carbons are on this right-hand side? We've got 1 here, 2, 3. Okay, so that's going to be propyl. Of 3 carbons. How many carbons on the left-hand side of the molecule? 1, 2, 3, 4. Remember, there's a carbon right here in the carbonyl. So it's going to be propyl. What's the name for 4 carbons? Butanoate. Okay, propyl butanoate. That is our ester right here. Not too bad. Hopefully you guys are okay with skeletal formula. All right, guys, here's a summary for you. Making sure you know everything you need to from the specification. Let's go through this real quick. Feel free to just read through this or end the video if you're happy here. But I'm going to run through a summary just so we've checked everything off that we need to. Esters are derivatives of carboxylic acids and alcohols, okay? And they are formed via esterification reactions. Just try and remember that name. They contain the ester functional group, which is the COO. You're normally going to see an R group here and an R prime on either side. And this is polar, okay? Remember they're polar, which allows them to be used as solvents, whereas they cannot form hydrogen bonds with one another. Esterification is a reversible reaction. Remember this symbol right here. Condensation reaction, that is the general name of an esterification reaction. It requires an acid catalyst, and this is often sulfuric acid. Okay. Next one, esters can be hydrolyzed under both acidic and alkaline conditions. Easy, HCl, NaOH. Okay, both of these are dilute. And they yield alcohols and carboxylic acids when reacting with acidic conditions, or carboxylate salts and alcohols under alkaline conditions. Okay, really remember that part. And also remember, something I haven't included here is this is reversible when you're reacting with an acid. This is not reversible. Okay, remember that as well. It's really important. Esters are widely used in various industries due to their properties and pleasant aromas. They are used commonly in solvents, plasticizers, perfumes, and food flavorings. That is the video, guys. That is esters done. Hopefully it sets you up with some good revision. Did some practice questions. You know how to name it. You know the structures. You're going to absolutely smash any ester question that comes up in your exam. Hopefully you found this video useful. If you did and you want to see more content like this, like the video. It really helps the channel grow. Best of luck in your revision and upcoming exams, guys. Until next time, peace.